Well, welcome to this video. We're going to talk about Matlab, a little bit of an introduction. The reason we're using Matlab and Simulink in our Mechatronics class is several reasons. It's a good tool to help understand how these systems work because we can build models of them and exercise them. It's a good tool to learn for when you graduate and you're out in industry and you're going to, a lot of companies use these tools. And I've had more than one student come back and say, well, I'm glad I learned Simulink because I just had a job interview and they asked me about it. So it's good stuff. It's a very powerful tool. It's probably the 500-pound gorilla of mathematical simulation kind of tools. And you'll see it everywhere. So we're going to start out with a brief introduction. You should have seen this before, okay? But we'll go through it quickly. If you've seen this before, obviously you can, just the Matlab part, you can kind of gloss over this and move on to the regressions and Simulink videos I'm going to do. If you're not real comfortable, I'd suggest you follow through, open up Matlab right now, and as I do things on my screen, you can pause the video, try them on your screen, and make sure that everything's working for you and make sure you understand it, because we will be using Matlab and Simulink almost non-stop through the class, and you're going to be using it for homework, and you're going to be using it on tests, and you don't want to be in a position where you're struggling with the details of Matlab when you should be solving a problem on a test. So you probably don't need to look at me. I will close off this video, and then we can get to Matlab itself. Okay, so here is the Matlab screen. The main window here in the middle is the command window where I'll be typing commands. There's a window over here that lists all the variables in our workspace. This is a history of commands here. So you can go back and remember what you did or even copy and paste from that window. And over here on the left is the list of files in the current directory, which is very handy. Oh, and one other thing I'll say about Matlab. Unlike a lot of software products, I find that Matlab's help is helpful, and I refer to it often myself. But let's get started with a couple of real quick basics. Creating variables. To create a variable, I'll create A equals 2, carriage return, and I see that it tells me that A is equal to 2, and it also put A in my workspace variable list. Now, Matlab is case sensitive, so if I create capital A equals 4, now I have two different variables, lowercase a, which is equal to, uppercase A equals 4. I can do B equals A plus A, A, and I get 6, okay? So that reflects all those values. Now you see Matlab is echoing the results every time I do something. That's sometimes useful, but a lot of times we don't want to do that. So if I say that D equals 2 times B, uppercase B, and I put a semicolon on the end, let me move the cursor out of the way. If I put a semicolon on the end, it will suppress that echo of the thing, and so it just does the math and doesn't tie up our screen. And you can see now we've created A, lowercase a, B, and D. Okay, simple things. To create arrays, there's a couple ways to do it. If you want to create a row, I can say that our W equals bracket 1, 2, 3, 4, 5, 6, 7, close the brackets, and I'll leave the semicolon off, and you can see we created a 1 row by 7 column array. To create a column, I can say CL equals, I can do it as a column, 1, carriage return 2, enter 3, enter 4, enter 5, close it off. Now I've created a single column with 5 rows. Or if I didn't want to type it that way, I can use the semicolon as a end-of-line terminator. CL2 equals 1, 2, 3, oops, I'm doing a column, not a square, 1 semicolon, 2 semicolon, 3 semicolon, 4, and I created a column vector that way. I can create arrays of a certain number of columns and rows. The only thing is the number of elements in each row has to be the same, so I can say SQ, I'll create a square matrix equals 1, 2, 3, semicolon, 4, 5, 6, semicolon, 7, 8, 7, 8, 9. And instead of semicolons, I could have put in a carriage return just like I would have done, like I had done before in the column. Now I create a square array. I can do math on that array. I can multiply it by scalar. I can say that XX equals 3 times SQ. Ta-da. Okay, pretty easy. But we got to be a little bit careful with our math operators because the Matlab recognizes two basic types of operations. There's matrix mathematical operations, and there's element by element array operations. One uses like a star, like a times, like I did, and the other is a dot times. Now when I'm multiplying by scalar here, it doesn't matter if I say XX equals 3 dot times SQ. I get the same answer because I'm just multiplying by scalar vector. But if I say SQ times XX, this is matrix multiplication, okay? So what I've done is, well, let me do this here. SQ, show you what SQ looks like. XX and SQ times XX, make it easier here. So we've done matrix multiplication, right? So this 90 is equal to SQ is first. So it's 1 times 3 plus 2 times 12 plus 3 times 21, and that should be equal to 90. The 108 here came from 1 times 6 plus 2 times 15 plus 3 times 24, and that gave me that, and so on. So it's just your basic matrix multiplication like you learned in linear algebra. On the other hand, if I take, say, SQ dot times XX, I get element by element multiplication. And it kind of scrolled off my screen. See if I can get it back fairly. Okay, so my answer here up in the upper left-hand corner of 3 is obviously 3 times 1. The 12 is 6 times 2. This 27 is 9 times 3. So it's just doing an element by element operation or multiplication as it goes through each element in the array. So it's treating it as just an array of numbers and not as a matrix. I said that the help is useful. ELP ops for operators. That's something worth remembering. Help ops. And it gives you the list of all the arithmetic operators and the relational operators, what the syntax, and you can click on any one of these. And this is real handy because if you're writing C all day long and then you got to switch over to Matlab and the syntax is similar but not quite the same, you know, and it's easy to get confused and you just type help ops and, oh, okay, not equal to is the tilde equals, you know, things like that. And it'll straighten you right out. And you can see also there's the matrix multiply here, which is a star, the array multiply, which is the dot star. Okay. One more operator I want to point out is the colon operator when you're creating an array. I want to say that let's create a variable x equals, we'll start at 0, we'll increment by 0.1, and we will end at 2 times pi. Pi is a built-in variable. Oops, I forgot the colon there. Go back. So now we should see 0, 0.1, 0.2, 0.3, 0.4, all the way to 6.2. So 0, 0.1, 0.2, 0.3, etc., all the way to 6.2. And obviously, since we're incrementing in multiples of 1/10, we don't get exactly to 2 pi, right? So we get as close as we get. And we've created 63 elements. There's a lot of built-in functions. Y equals sine of x. And I'm going to put a semicolon there so that I don't clobber the screen. And what I've done is I've created a variable and another variable that is a sine of that variable, and now we can start playing with plots. So let's, just like help ops, help plot gives you good information, and basically what we're going to do is we'll say plot and the x value variable, the y value variable. If I want to specify the color of the line, I can put strings in, and the syntax is there. There's an example here. Plot x, y, comma, quote, c plus, colon, quote, plots a cyan dotted line with a plus at each data point, etc. Okay? It gives you examples. If you have multiple things on the same plot, it shows you, it's basically x1, y1 with the format string, x2, y2 format string. So just type help plot if you get confused. We'll do some here. So I created x and y. I just plot x comma y with nothing fancy, and we get a simple plot like that, and it looks like a sine. What a surprise! I can add a grid, makes it look a little better, and let me rearrange these windows just a bit. Slide that off of there. Hopefully I didn't slide it too far on your screen. Grab the plot. I'll move it over here so then we can see the changes happen as they happen. I can even slide this a little further. Okay. I can add titles. And it's a string in quotes. This is a title. And it appears Y label and X label. And, you know, normally you'd want to put something useful here, like we could call this time, seconds. And of course, I'm inconsistent in my capitalization, but that's life. And you can, you know, build these things up, and you can go into the plot itself and edit it. If I click here, this is the edit plot. I can click on a line, right-click, and I can change the line style. I can change the line width, which make it a line width equal to 2, get fatter, things like that. Okay, lots of things we can do. Now, suppose I want to overlay a cosine. How can I do this? Well, I've got a sine plotted. I can hold the plot, H-O-L-D, on. Now, this plot will stay there, and anything I plot will just get overlaid on top of that. So I take plot X, and I can plot the cosine of X, and do the math right in there, and I'm going to make this a red, that's either dotted or dash line, I forget. I have to type help plot to remember all of these codes. Oh, and I got to close the quote on that. Okay, so there's a red dotted line, maybe a little bit hard to spot, but we have the sine and cosine one on top of each other, okay? Now, if I had wanted to plot those all in one command, I can say plot X, comma, Y, comma, quote, R, quote, so it'll be a red line, and I didn't like that dot. It was hard to see, so I'm going to change that to a dash dash. So I've got an XY pair, a format string, XY pair, a format string. And why did I make them both red? Let's change that. Let's make this one black. Okay, and there it is, and I can put on the grid. One other useful thing is the legend, L-E-G-E-N-D. First string is whatever you want to type about the first curve. I'll just call that first curve. Close quotes, comma, whatever you want to label a second curve, we'll call this cosine, quote, and close my parentheses, carriage return, or I guess it's enter nowadays. And there you have, I've created a legend, so you now that, and I can move it around, so you know the red line is the first curve and the black dashed line is cosine. Okay? A little bit more. Matlab has the capability to put multiple plots in the same window by using a subplot. Let's type help subplot. I can't even type anymore. What subplot does, and we'll go up here, it creates MNP, or subplot MNP, breaks the figure window into an M row by N column matrix, okay, of small axes, and selects the piece axes for the current plot and returns the axis handle. So if it's basically counted along the top row and then second row. So subplot 211 creates an array of 2 rows, 1 column, and it accesses the first one. Subplot 212, 2 rows, 1 column, second one. We'll do subplot we'll make 2 rows, 3 columns, and we'll access, well, let's see, if I want to do the first one in the second row, I'll count 1, 2, 3, 4. That's the 4th element in that array. And so there would have been 1, 2, 3, and this is the 4th one, and I can plot anything there. I can access, you know, the second one will be in the middle of the top row, and so on. So I can create windows with multiple plots, you know, if I want to have different variables, say a variable that's scaled 0 to 10 and a variable that's scaled 0 to 100, I might, you know, do a subplot 2, 1, 1, 1 for the first one and 2, 1, 2 for the second one, and then the fact that they have drastically different y-axes or something doesn't matter. You can still see how they both relate to each other as a function of the x. Okay? Script files, I mean, this gets tedious typing this stuff over and over. Matlab has a capability of creating files, putting them in a script. Let's pick this one here. I can open the script by simply double-clicking there. Boom, it opens. I can type in commands such as I want. Here I've created a list with student names. This is from a few semesters ago. And because this is in curly braces, it's actually a cell array. You won't need to do that much for this class, so I'm going to ignore it. But if I click on here, it runs and it executes and gives me a name. Okay? If I run it again, just give me random names. I just keep running it, and I get all these names by default. Okay? What was that? And then in the next video, what we'll do is we'll look at this plot here, this script, the polycurve fit and regression example. If we get a chance, that might be 2 videos. We'll see how the time goes. Just so we can show you how these run, and you feel comfortable with this, because you'll need to use these for your. Let me close that. If I run this again, you'll need to use these for that first homework assignment, and I want to make sure you understand what it is. I tried to put comments in here, using that parenthesis or the percent character. Put the percent character, everything beyond that is a comment, so it's just information for you. But we'll kind of break this apart step by step and see what we can do with it. So let me go back here, and I need to stop the archive and see you in a bit.